opportunity to work through hands-on exercises and practice implementing a wide range of features and topics, all while being guided by and asking questions of an expert trainer. Now, for more in-depth questions, you also have the opportunity to schedule individual office hours with our trainers and are able to have code reviews or more detailed discussions one-on-one. There is also a substantial Xamarin community that you'll be introduced to, and a private forum just for Xamarin University students where you can interact with other students and trainers. And finally, you have the opportunity to also become a Xamarin Mobile Certified Developer. So I highly encourage everyone to come on over to Xamarin University, check us out, and sign up for a free trial. Now, as I mentioned, we have a full day of training planned for you. We're going to be building an app together over the course of the day, from start to finish. So let's quickly go over our agenda for the day. First, I'll start us off right now, and I'll introduce you to Xamarin and the Xamarin Mobile Platform. We'll also cover setup and help you get prepared for the rest of the day. Next, Renee Rupert will start our project, and he'll introduce you to Xamarin.Forms, the powerful and really popular cross-platform UI framework from Xamarin. After Renee, Jesse Dietrichson will continue building on our app and talk about the choices that developers have when designing a Xamarin.Forms user interface. Now, almost every mobile application will take advantage of a cloud-based backend, and in the next class, Jason DeBoover is going to teach us just how easy it is to add an Azure backend to our Xamarin apps. As you might know, mobile users are rather unforgiving customers, and it's imperative that we ship high-quality apps to the app stores and into our users' hands, and that we understand how those customers are really using our apps. Glenn Stevens will walk us through the different ways to test our apps to be sure that our customers are truly delighted. He'll also teach us how to integrate analytics into the application pipeline so that we can monitor our app's behavior in the wild. And then finally, we'll finish the day with Kim Philpotts, who will introduce us to Hockey App and the just announced Visual Studio Mobile Center to integrate deployments and DevOps into our mobile application lifecycle. Now, as I mentioned, we'll be building a single application over the course of the day. We're going to be building an exam preparation app to quiz you on Xamarin topics. It will be built with Xamarin.Forms, which means that this one app will run on all the different platforms. At the end of the day, we'll also open source the app, so you'll have access to all of the source code that we're working on here today. Now, throughout the day, we encourage you to ask questions in the chat room. Our Xamarin University trainers and staff will be answering questions there as the day progresses. And although Xamarin has been around for a few years now, and a lot of people are very familiar with it, it is still new to a lot of people. So we're going to start with an introduction to Xamarin and the Xamarin Platform. Xamarin is your entire mobile solution when it comes to app development and testing and analytics. The Xamarin Development Platform is usually what we talk about. It's probably what you think of when Xamarin's mentioned. And this is where you can leverage your C# and your .NET skills and libraries to build native iOS, Android, and Mac apps, and share your business logic code with Windows, all from within Visual Studio. We also have a few testing products, including the new Xamarin Profiler, which lets you identify hotspots in your app, and Xamarin Test Cloud, which enables you to find bugs before your users do, by allowing you to create automated user interface scripts, which you can run locally, or you can see them run on hundreds or thousands of physical iOS and Android devices. Glenn's going to be covering that testing a little bit later today. And then finally, there's Hockey App for real-time app monitoring. And that is going to allow you to see what your app is doing and get detailed crash reports. And this is so important. And Kim will be showing us this at the end of the day. And as we've just revealed over the last couple of days, these last phases in the development process are of course being integrated into the new Visual Studio Mobile Center platform. Keep in mind, it's not all there yet. It's just a preview today. In fact, we will still use some of the legacy portals today to get to some of the information. But our goal is to integrate all of this together so that you have a one-stop portal to manage your release builds, your UI testing, your beta deployments, and collect all your runtime analytics. I'm really excited about the Visual Studio Mobile Center. I think this is going to be a tremendous enhancement for developers. Xamarin University is going to train you on the entire platform here today. Not just the development, but also how to take your app from your concept all the way to publishing and versioning and deployments. Before we get into the details, though, let's talk a bit about the different approaches that companies and people often take when they're creating mobile applications. So we're going to very briefly look at 3 different ways to create a native mobile application today. We have the silo, the black box, and Xamarin. There's also the responsive web design, but that's not really a mobile app, more of just kind of a mobile portal to some bit of information. It's absolutely a valid way to access information from a mobile device, but it's not really the same as building an application. So we're going to leave that out of our comparison here today. So let's look at all three of these approaches and the pros and the cons of each one. We'll start with the silo approach. And this is very, very common, particularly for larger organizations. And this is where we write the same code 3 times, once per platform that we want to target. Each of these apps are going to be built using the vendor's tools and the vendor's languages, like Xcode and Swift, Android Studio and Java, or C# or Visual Basic and Visual Studio. Of course, there are some benefits to this approach. You'll get a fully native application, and you're able to fully take advantage of the platform and its nuances. Also, you're going to get great documentation from each vendor and the large community surrounding them. On the other hand, this type of development is very expensive. You'll be developing and maintaining a completely separate code base for each platform, likely with a separate team for each one. And that means 2 or 3 times the cost for the application. Also, there's no code sharing going on here, so synchronizing features and fixing bugs can be painful. A lot of the time, you'll have one platform ahead of the others when it comes to features as well. The second approach is to use some sort of magic black box that takes a single code base, usually written with JavaScript and HTML, and produces a native app for each platform. And there's several vendors out there that do this, and this can definitely be an appealing approach which solves the silo problems. With this approach, you have one code base and you have one team. Because it's using HTML and JavaScript, which are very popular and very well known, that one team could even be the same team that works on your website. The drawbacks, though, are that features are commonly tied to the least common denominator across all the platforms. You can't really take advantage of everything in each platform. And additionally, the UI for these apps tends not to feel native. You can usually tell which apps are using HTML instead of the native controls. And then finally, we have Xamarin. Xamarin lets you build iOS and Android apps using the C# skills that you already have. Because the code is written in C#, you can share large sections of it with your Windows Phone or your desktop applications. And Xamarin doesn't build any tooling specifically for Windows Phone, so with Windows and Windows Phone, you're going to be using the other Microsoft tools directly. With Xamarin, you still get fully native apps. They're built using the vendor's tools. And that means you get to use and leverage the language and the framework that you know, using one team of developers. Xamarin lets you share the business logic that drives the app on all the platforms. Shared code means faster development cycles and fewer bugs. Xamarin also gives you full access to the underlying platform with same-day API support. But even if that fails, you can still access the native APIs directly. There's also a large selection of third-party APIs as well as .NET libraries. And the sharing will only get better over time with the .NET Standard initiative. Also with Xamarin, you're not getting that lowest common denominator experience, but instead the UI can be crafted on a per-platform basis. Now, using Xamarin does have some issues to consider though. We're introducing another runtime on top of the native operating system, and it's possible that the runtime platform and the tools might have their own set of bugs. And with Xamarin, you still have to learn the native platform APIs. We're not hiding that from you. And this is all referencing the traditional Xamarin approach to development, where we have a shared C# code base with all of our logic, and then we define the UI, the navigation, and the user features through platform-specific code. And we're going to be using the same basic tools and file formats that the native vendor tools use. And this is often what you're going to want to use when you're creating your application, because it lets you craft the application to the capabilities and the UI platforms for each platform. And you can really take advantage of each platform fully. Now, you might be worried about API coverage. Apple and Google are constantly adding new features to their respective operating systems. Can you use all the features available to Swift developers, for example? Can you use all of the new iOS 10 features? Well, the answer to that is yes. Xamarin has 100% API coverage, but all accessible in C#. And what about Android? Well, it's the same story here. 100% API coverage, and again, all available in C#. And of course, when it comes to Windows, Microsoft already provides all of their development tools and APIs in C#. One of the big differentiators with Xamarin is this. Anything you can do in the native platform tools and languages, you can do in C# when you're using Xamarin. Nothing is restricted. Every feature is available. The only difference is you can use C#, and you can use lots of the great features of .NET, like link and async and await and generics and delegates and tasks. It makes writing mobile applications a pleasure. Now today we're going to focus on handheld mobile devices, specifically phones and tablets. But keep in mind, Xamarin also fully supports other iOS and Android devices. You can create apps for the Apple Watch, Apple TV, Android Wear, Amazon Fire TV, Mac desktop apps. We support all of them. Now, so far, we've just been talking about the traditional Xamarin development model, where we share our business logic, but we create a unique UI for each platform. But there's another way, though, and that's Xamarin.Forms. Xamarin.Forms allows for even more code sharing in the form of a shared UI definition, which can be done either in C# code or in XAML. XAML is a markup language defined and used in the Microsoft world, and it's likely familiar to many of you. Xamarin.Forms is good for most applications that want to target all the popular platforms, unless you want the look and the feel to be different on each platform. Now, Xamarin also offers exceptional performance on each platform. For iOS, your application is a fully compiled binary, which is going to offer you all the performance you'd expect of a native compiled binary. On Android, Xamarin leverages just-in-time compilation, just like a Java Android application, to create an optimized executable on whichever device is executing the code. So Xamarin offers native performance, and with all the language advantages of C# and the runtime advantages, it can even create applications that are faster than apps written in the native languages. Now, one last thing I want to share with you before we start talking about setting up the Xamarin environment on your machine. Xamarin is now also completely open source. Because it's open source, you can download the source code, you can review the code to see how things work, you can add features to extend the platform. And if you want to contribute, Xamarin takes pull requests. We would love to get your contributions back into our code. Now, let's take a break from the slides for a bit and see just how quickly you can get started with Xamarin. Later today, you're going to get some hands-on experience creating a complete Xamarin.Forms app. Right now, though, I'm going to quickly build a cross-platform app using the traditional Xamarin native platforms. I'll create an app that uses shared code to get the current weather from a city that we specify, and I'll run it on iOS, Android, and Windows. In order to figure out the current weather, I'll need an API. Luckily, there are lots of them out there. I'm going to use openweathermap.org. It has a nice RESTful API. So I can pass in the city, the types of units, which would be metric or imperial, and my API key as part of the query string. And it's going to return some data back in JSON format. And this architecture is very common in mobile apps. And almost all apps will need to connect to some API and get some data back. I'll be using Visual Studio 2015 Enterprise, although just about everything that you see can be done completely for free using either Visual Studio Community on Windows or Visual Studio for Mac. Let's start with iOS. I'll come to the menu and choose File, New Project. And we're presented with a lot of built-in templates. When you installed Xamarin, you installed new templates in the iOS, Android, and cross-platform categories. We'll come down to iOS, expand it, and choose Universal. And these are apps that will run on iPhones and iPads. I'm going to choose Single View App because it gets us started with a single screen and a storyboard designer. I'll name this crossweather.ios. This is going to be the iOS native application. I'll create all of the native UI and tap into any platform-specific APIs in this project. Over in the Solution Explorer, you can see all of the files that were created for me. And the structure here would be familiar to anyone that's done iOS development in Xcode. We have iOS components like asset catalogs, resources, our app delegate file, a view controller class, and a storyboard designer file. Let's open that storyboard file. Here, we can start designing our app. If you've used the Windows Forms, or Web Forms, or the WPF Designer in Visual Studio, this is very similar. It gives us a drag and drop experience for iOS, right here in Visual Studio. Now, our weather app is going to need a place for the user to enter the city, a button to go get the weather data, and we'll add 3 labels for the data. Now, although the API returns a lot of data, we'll just work with the latitude, longitude, and current temperature for this app. I'll open the toolbox, and here we have all of our controls that we can add to our app. First, I'll add a text field for the city input. In order for iOS apps to have a responsive layout and look good on all the different screen sizes and resolutions that we need to support today, we'll use Apple's auto layout system to size and position our controls. Next, I'll add the button that the user will press to go get the weather. Notice we have access to the properties of the control, and I'll give it a name. I'll do this so that we can access the button in the C# code and we can listen for the touch event. And I'll just resize and position the button here. Next, I'll add the labels. Now, notice as I'm dragging the label around and resizing it, the designer is giving me some guidance on the best place to position it so that it follows Apple's design guidelines. We'll name this label Latitude and change its text. And I'll go ahead and do the same for longitude and the temperature labels as well. At this point, we have an iOS app that we could run on a simulator or a device. And that wouldn't be very exciting though, because we haven't written any code to make it do anything. So we need to write a little bit of code that's going to go out to our web service, download the data, and display it on the screen. We also want to support multiple platforms when we do this. So we don't want to put this code right into our iOS project, because we couldn't share that code across all the different platforms. So instead, we're going to create another project and add it to our solution. In the search box, we're going to search for portable because we're going to be adding a portable class library. Renee will talk about portable class libraries in his session later today. You can see here that we have a template of a class library that's portable and supports iOS, Android, and Windows. That's exactly what we want. We'll name this crossweather.core. We'll start out with just a simple class1.cs file. What I want to do though is add a class to retrieve our data from the weather API. So I'll rename this weatherrepository.cs. We can add a constructor, and we're going to allow the user to specify the city, so we'll pass that in as a parameter. we're going to need to build up that query string that we saw earlier to invoke the Open Weather Map API. I've already written that code, so I'll just create a class here and name it API Settings. And then I can just copy the snippet of code into the project. The repository class will need that URL, so we'll grab it from the settings class. Next, we need a method that will actually go get the data. The really nice thing here is that because we're using C#, we get to use things like async and await. This is an amazing experience when building mobile apps that need to stay responsive to the user. This method is going to need to return a task of something. But what should we return here? We're going to want to return a strongly typed C# object, which we'll name weatherRoot. Let's go ahead and create a class for that. And if we go back and we look at the data that's returned from the API, we can see the structure of the JSON that's returned. We can see at the top that it has a key called city, and in there's a key called coord for coordinates, and there's the latitude and longitude that we're going to display. So again, I've already created the code to mirror that structure in C#, and I'll just drag and drop that in our weatherRoot file. We can see here that we have a weatherRoot class. And this is the class that our getWeather method will return. So we'll create the variable to hold the data. And now we need to go out to the web service and download that JSON data. Because we're in a PCL right now, we'll need to add a NuGet package. And this is another example of the power of the ecosystem of Visual Studio and .NET, because there are a ton of NuGet packages that already exist that we can add right into our mobile applications. And if we search for HTTP client, this will allow us to use Microsoft's HTTP client class, and it gives us a modern, first-class async API to access remote web services on all of our platforms. Let's add the appropriate namespaces. And now we can use the getStringAsync method to retrieve that JSON string. Oops, it would help if I moved this method into our class. So now we're getting the JSON string back, but we want to return a weatherRoot object. So we need to map one to the other. Again, we'll turn to NuGet and another NuGet package. In this case, we'll add one that most people are probably already familiar with, which is JSON.NET from Newtonsoft. Again, we can use these common packages in our mobile app. And now we can use JSON.NET to deserialize the JSON string into a weatherRoot object. And of course, that JSON string might be fairly large, and deserializing it might be a CPU-intensive task. So we should do that on a background thread as well. Coming back to the iOS app, we can wire up the touch-up inside event on the button to create our repository, pass in the user-specified city, get the weather object back, and display the results on the screen. Of course, we will need to add a reference from the iOS project to the PCL first. And now, we can run the app in the Xamarin iOS simulator for Windows. And this is an enterprise-only feature, but it's really cool and it makes developing for iOS on Windows super easy and pleasant. We'll let the simulator boot up and install our app. And let's see what the weather is like here in Detroit in mid-November. We get our results back and 58 degrees Fahrenheit. Now that's a little chilly. Let's try someplace warmer. How about Miami, Florida? 81 degrees. That's a little bit better. And I just took a trip to India a few weeks ago, so let's check that out. 70 degrees? That sounds perfect to me. Now we have one app on one platform complete. And because we put our weather logic in a PCL, we'll be able to share that code across all of our platforms. Let's see how easy it is to add Android now. We'll add a new project. And we'll scroll down to the Android category. We'll choose the single view app again and name this crossweather.droid. Let's collapse some of these and we'll make the Android project our startup project. And just like we saw with iOS, the Android project is using the native platform's idioms and structure. We have a main activity and a resource folder, including a main layout file. We can open that in the Android Designer to start creating our app. And by default, Xamarin includes a sample button on the screen, and we can remove that. Now, let's go back to the toolbox and get a plain text field for our city input. We can drag and drop that onto our designer and change its text to read city. We want to access this field in our C# code, so we'll give it an ID. And notice that we're using Android's ID syntax here. Next, we'll add the button and we'll change its text right here in the designer. And we'll change the ID as well. And let's add our 3 text labels, starting with latitude. And then we'll add longitude. And finally, we'll add the temperature. In the main activities code, we'll delete this boilerplate code from the template, and we'll add the code to wire up our weather repository. Notice that this code is very similar to the iOS code that we wrote before. It's creating a weather repository class, passing in the city, getting the data, and displaying it on the screen. But also notice that we're using native Android APIs like Find View by ID. So you get the best of both worlds with Xamarin. And of course, to access that shared code, we'll need to add project reference to our PCL. And add the appropriate namespaces. And that's it. That's all we needed to do for Android. Let's go ahead and run this in the Visual Studio Android emulator. Now this time, let's see what the weather is like in Paris. Only 41 degrees? That's actually colder than I expected. How about Tampa, Florida? And someplace I expect to be cold. How about Moscow? Yep, only 19 degrees there. And finally, let's add our third target platform to our solution. This time, we'll open the Windows category and choose the Universal Templates. Here, we'll choose the blank app template and name it crossweather.win for Windows. I'll just accept the defaults for the target and minimum platform versions. Creating the Windows app is going to be very similar to the Android app, because all we need to do is create a native platform UI and wire it up to our existing shared code. Let's add a project reference to our PCL here. Now we can open the main page.xaml file. Let's zoom in a little bit so we can see this better. Just like before, we'll add one text box, one button, and 3 labels. Visual Studio gives us a really nice designer for the XAML files. So there we have our city text box, and now we can add the button. And of course we'll add a text block for latitude. And a text block for longitude. And finally, a text block for temperature. We'll open the code behind file and add the code to create our weather repository and wire it up to our UI. Now, let's run this in our emulator. This is Windows Phone, so of course I'll have to use Redmond here. And there we go. So in just about 20 minutes, we were able to create 3 native mobile applications, targeting thousands of devices and millions of users. Alright, so before we continue with our day and we start writing our exam application together, you'll need to be sure that you have the Xamarin tools installed on your machine. You can use either a Mac or a Windows PC as your development machine. If you're on a Mac, you'll be able to develop for iOS and Android using the new Visual Studio for Mac IDE. On Windows, you'll be able to target iOS, Android, and Windows platforms, all using Visual Studio. Xamarin is included in the installer for every version of Visual Studio 2015, including the Community Edition. And this means that you can get started building Xamarin apps completely for free. If you're using Windows, you'll need at least Windows 7 and at least Visual Studio 2012. And of course, we recommend the latest release version with all the applied updates. Like I said, you can use Visual Studio 2015 Community Edition, which is free. If you don't have Visual Studio installed yet, the Xamarin tools can be installed directly from the Visual Studio installer. If you do already have Visual Studio installed though, you can download the Xamarin installer for Windows from Xamarin.com and then just run the setup program. It will go through and install all the required SDKs and all the build tools and add all the integration pieces into Visual Studio. So to install Xamarin with Visual Studio, just select the custom installation option and ensure that Xamarin is checked under the cross-platform mobile development section. Now, one thing to be clear on, you're able to do all your development on a PC with Visual Studio even when you're creating iOS applications, But the Apple licensing requires that we build and compile the application on a Mac with the Apple SDK. And that means that we can't do everything on the Windows side. And it also means that you will need a Mac to actually do the final compilation step for iOS. Xamarin solves this through a service installed on a network-connected Mac known as the Xamarin Mac Agent. Visual Studio connects to that process, and it delegates a portion of the build to that Mac, which allows us to compile with the native toolchain and launch the Apple-provided iOS simulators. So that this means you're going to need to run the Xamarin installer on your Mac to install the build host. Our wizard is going to walk you through the setup process to enable access from your PC. Now, when you create or you open an iOS project within Visual Studio on Windows, the IDE will connect to the Mac agent. And again, a Mac is only a requirement for iOS applications, not for Windows or for Android. When you're using a Mac, either as a build host for Windows or as your main development environment, the first thing you should do is install Xcode. You need the latest Xcode from the App Store, which means that you likely need the latest version of Mac OS as well. Once you've got that installed, download the Xamarin installer from Xamarin.com and go through the install process. This will install the Xamarin development environment, Visual Studio, as well as the Android SDK tools automatically. There are a lot of downloaded components that have to be installed from various locations, so this is going to take anywhere from 10 minutes to an hour depending on your internet speed. Once it's finished, you'll be ready to start building Android and iOS applications with Xamarin. So here's the basics of how the Mac agent works. When you create or open an iOS project with Visual Studio on Windows, the IDE will attempt to connect to the Xamarin Mac agent. If you've established a connection in the past, it's going to remember that connection and try to reconnect. If it's unable to connect, or you're not connected to a Mac agent yet, then you're going to be prompted to connect to a Mac host. Visual Studio connects and interacts with your Mac using a secure SSH login. Now, remote logins are disabled by default on most Macs, so you're probably going to need to do a little bit of setup before you can connect to the Mac host. The connection wizard is going to walk you through all the necessary steps to turn on the SSH support. So you're going to go over to your Mac, and you're going to log into the Mac that you want to use and access the Sharing Preferences app, as you can see here on the slide. Select the checkbox next to Remote Login, and then make sure your user ID is listed among the allowed users to remotely access this Mac. Also, the Mac host itself has to have all the development tools installed on it. So the setup that we just walked through for creating a Mac development machine, that all has to be applied here as well. Again, Apple legally requires that you use Mac hardware according to their license agreement, and we should always make sure that we're using the latest release version of Xcode. Also, make sure that you periodically update the tools here on your Mac as well. Treat this machine just like your development machine, even if you're using Visual Studio on Windows for your actual development. Also, you can connect Visual Studio to multiple Mac hosts. And this is done by identifying the host on the network through either its name or its IP address. So maybe you might use multiple hosts to allow for different versions of Xcode, for example, if you wanted to test pre-release versions or beta versions. Once you identify a host, it will ask for login credentials, and these will be used to create a secure connection to the host. And this must be an administrator account, and the machine is going to be saved off in a list of the available build hosts so you can connect again next time. The passwords are not cached off. Instead, it just creates an SSH login key, which is going to be used to sign in each time. Also, you have to supply the username here, not the full name that you normally see on the Mac side. If you don't know how to get that, you can simply open a terminal prompt on the Mac and type, "Who am I?" all one word, and that will tell you what your username is. Or you can go to the User Settings app to see your username. Now, opening or creating an iOS app on Windows is going to create that secure connection to the build host, and it will launch the various agents needed to support the design and the build processes. Again, it uses SSH to log onto the machine and start the daemon processes. These agents are all launched over the secure shell. The build machine doesn't need to be logged in or have any process running. And then progress of the agent launch is all reported in the Xamarin output windows in Visual Studio. Under the covers, multiple connections to the build agent host are actually going to be made here. The first SSH connection is from Visual Studio to start the coordinator, and that's going to get the list of simulators and connect to the iOS designer so you can actually start your development. Also, Visual Studio launches an MS build process for each build, which will create a unique SSH connection to the host to drive your actual compilation in your build on the Mac. In addition, multiple instances of Visual Studio running on a single computer can share a single build agent machine, but they're each going to create a unique SSH connection. And this allows you to open multiple solutions, for example, and work on multiple projects at the same time. And then finally, to allow for command line builds, the iOS build commands take some additional parameters to support the server address and the username and the password. So if you want to integrate this into some continuous integration or some DevOps lifecycle, like we'll be talking about later today, you absolutely can do that. And once everything is installed, you're going to want to check for updates. On Windows, you can use Visual Studio, and you just go to the Tools menu, and then Options, and then Xamarin, and then you just click the Check Now link under Updates. On the Mac, you can use the Xamarin menu, and then check for updates, and you get the same dialog here. No matter how you do that update, you're going to see a dialog similar to the one you see here. This actually has two things that we should pay attention to. First, it shows you any updates available for your system. Xamarin updates the tools fairly regularly to keep up with Apple and Google and Microsoft. The second, it lets you change the release channel. Xamarin has 3 different release channels. There's Alpha, which is where you're going to find the latest version of the software. That can often be a bit fragile and subject to change as it evolves. There's also the Beta channel, which has the APIs locked down. It might still have some issues, but the shape of the APIs likely won't change. And then we also have Stable, which is the released, fully tested version. You can switch between these channels anytime based on your testing needs, although we generally recommend that you stay on the Stable channel unless you need some new API that's not exposed in that channel yet, or maybe you want to check out some of the new announcements that we've just recently made and you want to switch to the Beta or the Alpha channels. Once you've got your development environment set up and you can build your app, then you're ready to run and test it. You have 2 options here. You can install your application onto different physical devices that you own, or you can run the app on simulated devices on your computer, and you do that through the use of emulators and simulators. Simulating the environment tends to be a little bit faster than using a real device, particularly for the whole build, run, test loop that we usually find ourselves in as developers. Also, simulators can replicate a huge variety of form factors and versions, which is going to allow you to test the software on different types of devices that you might not physically own. So for iOS, Apple provides an iOS simulator with the Xcode development environment. The Xamarin tools create native iOS apps, so we can use those same testing tools that you would use with Objective-C or Swift. The simulator can be launched with your application from either Visual Studio on the Mac or Visual Studio on Windows using the build host. On Windows, you can even use the iOS simulator for Windows from Xamarin. And this is going to show you the remote iOS simulator from your Mac on your Windows desktop. And if you have a touchscreen laptop or desktop, you can even interact with the simulator just like you would with a real device. And the simulator supports a variety of different devices and resolutions as well as different versions of iOS. Now, only the latest version of iOS is usually installed by default, but you can use Xcode and you can go install older iOS versions also, and you can test your application for backwards compatibility. On the Android side, it's a little bit more complicated. You have several choices here. Google supplies a set of emulator images called Android Virtual Devices, or AVDs. It's a little trouble to get installed sometimes, but once you do, they're quite fast and they support a wide variety of devices and operating system versions. And the best way to install and configure the Google emulators is to use Google's development IDE. It's called Android Studio. This is not installed by Xamarin, but it's a free and separate download. Once you install Android Studio, you can create a new AVD image from the AVD editor, which can be launched through a toolbar button or through the Tools Android menu. So for Android Studio, you might need to create a dummy project to get to the full menu. Just go ahead and create any Android app and then delete it when you're done configuring your emulators. When you create a new emulator image, you can select from any Android operating system version, even up to the betas and the pre-releases. You can also select the device form factor, so phone versus tablet. You can select the resolution, and you can even use other Android devices like TVs and wearables and watches and things like that. And this is by far the most flexible emulator definition available today. And Android Studio provides a lot more options than just the standard SDK options dialog. So we definitely recommend this emulator for both Windows and Mac if you're primarily focused on Android development. It's a great emulator system. If you're a Windows user, you do have another choice though. Microsoft supplies an Android emulator based on Hyper-V with Visual Studio 2015. It emulates the accelerometer, the location sensors, and it supports turning the network on and off and even simulating the camera. Much like the Google emulator, you can choose different operating system versions and different form factors. There's not quite as many choices as the official Google emulators, but there are lots of different ones you can use here. You can start multiple virtual machines as long as you have enough memory to do so as well. Now, regardless of which emulator you choose, when you build and run debug builds of Xamarin Android applications, the IDE is going to try to update the app in place, rather than just uninstalling and reinstalling it. And this is called fast deployment. This is a project level option. You can turn this on and off. This is great because it reduces the amount of time necessary to build and get the app onto the device or the emulator. But with some devices and some emulators, it might not work properly based on the configuration of that emulator. So in that case, you might get a deployment error indicating that the app can't be installed on the device. If that happens, you can go into the project options for the Android project and turn that feature off. It's off by default for apps created with Visual Studio on Windows and turned on by default in Visual Studio for Mac. And then last but not least, we have the Windows Phone emulator, which ships with Visual Studio. This only runs on Windows, so if you plan to target Windows Phone, you'll need a Windows development environment with Visual Studio. In addition, this is an optional install, so make sure that you install that component in Visual Studio, or you can rerun the installer, and then you can modify the installed components, and you can get the tools and the emulator images. There's actually 3 different versions that you can install today. There's Windows 8.0, which is Silverlight, 8.1, which is WinRT, and version 10, which is the unified runtime with the desktop operating system. Each one can be individually installed or removed, and they all run in Microsoft's Hyper-V environment, just like the Android emulator that we looked at earlier. But one thing to note here is that Hyper-V is also an optional install. Visual Studio should turn it on when you install either the Android or the Windows Phone emulator, but if not, you can use the control panel and you can go add Hyper-V support. Also, Hyper-V interferes with other virtualization software, like VMware or VirtualBox. So if you need Windows Phone emulation, then you should go ahead and use Microsoft's Android player too, because it's based on Hyper-V. The Google emulators, for example, won't run when your Hyper-V is turned on. And then finally, as I mentioned earlier, you can run your apps on real devices. There is a bit of one-time setup that you have to do for each device, and all of that's going to be covered in the links that you see here. If you have some devices handy, it's a good idea to set them up for development so that you can use them for testing. Everything that we do today will work with the simulators and the emulators, but when you're developing production applications, a real device is very handy to use. Plus, you never want to ship an application without first testing it on real hardware, because it's going to have different performance and memory characteristics as compared to the emulators. Now, once all that's installed, you'll be able to select your runtime environment right from the IDE. So here you can see both Visual Studio on Windows and Mac. The options are going to change based on the startup project. So for example, on the right, you see the Windows Phone emulator installed in Visual Studio. On the left, we're using iPhone, and we have the different simulators there. In this introductory session, we've begun to see how to get started building native cross-platform mobile applications with Xamarin, using the tools and the languages that you already know. And this is an incredibly powerful solution, and it's one that's going to enable you to ship amazing applications. Now, before we continue, I want to give one more plug for Xamarin University. We've barely scratched the surface so far on the topic of cross-platform mobile development. And I definitely suggest that everyone takes advantage of Xamarin University's self-guided learning courses. And these are complete, free classes that you can take at your own pace, and they include videos, slides, and hands-on exercises for you. And it's a great way to learn more about Xamarin. And if you like what you see there, then definitely come to Xamarin University and sign up for a subscription as well. So that's it for me today. We have a full day of sessions ahead of us. Next up, Renee Rupert will start you on your path to creating your first app with Xamarin.Forms. And I'm really excited for everyone to learn Xamarin. And thank you to everyone for all of the questions in the chat room and for joining me today.